Here we go. Very rapid demo of a technology that is famously unreliable. Here we go. So yeah, I'm relatively new to amateur radio. I passed my foundation in March, my intermediate relatively recently. And like a lot of people, I started with one of these. It's a Krangshang UV-K6, 8, a number, 8. So I carried this around for a little while, and as you do, I lost the volume knob. Slightly annoying, still usable, but slightly annoying. So, here we go. I'm just going to flash through this, and then we'll go backwards and talk about it, because the demo takes a little bit of time to get going, so here we go. So, this is Printables, a repository of printable things. I went to there, I put in UV-K5, whole bunch of stuff for the UV-K5, and then a UV-K5 volume knob. Brilliant, that's what I want. I want one of them, please. So I press download. My internet stops working, but that's okay. Let's pretend that downloaded. This is what's known as a slicer. I'll go into what that means shortly. But what I'm going to do is, this is very awkward to operate from this angle, but here we go. Boop. I'm going to load my file that I downloaded. I'm going to press slice. There's going to be a bunch of complicated math that doesn't quite fit on the screen, but I'll cover that again in a minute. I'm going to press print, and I'm going to press upload. Hopefully, I've got enough working internet that that's going to behave. If not, I am prepared for that as well. No, okay, so I don't quite have enough internet, but pretend that did the thing. This is where it all goes horribly, horribly wrong. The slightly annoying thing about this being upside down is that it's quite hard to see what it's doing. Okay. That looks like it's doing a thing. We'll leave that alone. If somebody can just keep an eye on that and make sure it's not, caught fire or something. Right, so now that that's going, let's talk about 3D printing. So what is 3D printing? It's a broad topic and has some different things. It's known as additive manufacturing. Most manufacturing methods are subtractive in that you start with a thing and you chop bits off it to get the thing that you want. Additive is the reverse. You start with some raw material and you build it from scratch. There's lots of methods that come under 3D printing, some of which are accessible as a home person, some of which definitely are not. And generally, it's taking a thing, turning it into some layers, and then using some form of methodology to produce a physical object. It's become a catch-all term for a lot of techniques now, but generally that's what it is. So the three big types of 3D printing, again, there are many, but here we go. FDM, fused deposition modeling, that's this type of printer. You stick melted plastic together with heat. You take a glue gun, you turn it sideways, and you move it around a bit. That's literally it. SLA, stereolithographic addition, or something along those lines. You stick resin together with UV light. You have a vat of resin, you shine some UV at it, it goes solid. It goes solid and sticks to something, and then you move the thing up, and new layer under it, and you shine UV at it, and gradually you build it. builds a thing out of layers. And selective laser sintering, this is the other one you'll come across a bit. That's sticking metal together with lasers. Vat of powdered metal, you sweep it with a high power laser, you then apply more powdered metal. This comes up a fair bit if you look at, it is relatively natural to say, oh, I want to print things in metal. I would like metal objects. Last I looked, an SLS machine starts at £50,000 and prints a thing this big. When I say not all forms of 3D printing are accessible to the home user, that is one of them. But it does come up, and I would recommend you go and look at it. It is an interesting technique that's doing quite, it's changing a lot of metal-based manufacturing, particularly vintage car parts. But yeah, it's not something you can do at home. So I'm going to briefly touch on SLA printing. This isn't really this isn't a topic I'm going to cover, but it is the types of printing you have accessible as a home user are FDM, plastic, or SLA and resin. It's resin-based, UV-treated, and the machines themselves, the printers themselves, they're relatively stable now. They're between £300 to £1,000, depending on which ones you want to buy and what size you want. It's really good for very fine detail. Like if you play Dungeons and Dragons and you want custom miniatures, this is the type of printer you want to buy. The resin itself isn't particularly durable. You can definitely get engineering resins, but if you're paying £1,000 a kilo, then you probably don't want to be in this talk. And the other major drawback with SLA printing is the resin is pretty toxic. You do not want one of these in your house. Yes, you can buy carbon filters for them. Yes, you can do fume extraction and things. The point to make here is you can do all of those things, and you need to. It's not, you can't avoid it. It's contact sensitive. If you really don't want to get it on your skin and go out into the sun, because that hurts. Been there. But yeah, I kind of don't want to put you off. I just want to say these are the risks that it's the trade-off. But the level of detail you can get out of this is incredible. It looks like it's if any of you play Warhammer or anything, you can make those models, and it's easy. But yeah, the reason it's not covered particularly other than this slide is it's non-structural, it's not very robust, it's not really the kind of thing you want if you're trying to make things for radios. FDM printing. It's the most common form of 3D printing. This is kind of what people think of when you say, I've got a 3D printer. That's a Creality Ender 3. It melts plastic and sticks it to more plastic. 3-axis movement. There's many options when I say plastic, filament, many options, lots and lots of options. Lots of variations, lots of different capabilities, different capacities. We'll cover some of them. And this is where, if you're looking at getting into 3D printing or you want to buy a 3D printer to make your radio hobby easier or better, you need to make a decision here. Is your hobby 3D printing? Or is your hobby radio or something else, and you want to 3D print for it? That's quite a fine distinction, but if 3D printing is your hobby, like it kind of is for me, then you are going to spend all of your time working on 3D printers and never having one that works. If you are 3D printing for your hobby, then that's the point of this talk is that that is now completely accessible, but it will change what sort of printers, what brands, what manufacturers you're looking at buying, and kind of how much you're going to spend. Not a huge amount, but for a lot of people, it kind of, you start with, I want a 3D printer to do this thing, and then the 3D printer goes a bit wrong, and now, hey, you've got a 3D printing hobby. That's how it used to go. It can still go that way. It's how it went for me, but it doesn't have to. So, what do you need to do some 3D printing? First thing, you need a thing to make. You need a model. Otherwise known as, if you're Googling something or looking for something, going to Google and putting in volume knob, STL. An STL is a type of file, it's a stereolithographical file. They are the most common, 95% of 3D printed things are printed from an STL. There are plenty of places online where you can go and download them. I'll talk about them in a minute. So yeah, what do you need? You need a model. Your next job is you need a slicer, which is the program that takes your model and turns it into something that your printer understands. I'll talk about that in a minute. You need a printer. I mean, yeah. That's not actually true. There are lots of services online now where you can upload your STL and receive a printed file. Shapeways in the US, bunch of others in the UK. Probably a few of you may know friends who have 3D printers. Buy them beer, get 3D print, kind of works. And you need filament, which is the thing to make it with. An illustrative roll of some filament. So, finding models. On the left, we've got a suggestion for places to go. On the right, we've got programs that you might want to do some modeling in. Printables was the one I just shown. It's my recommendation. It's nice, it's clean, it's run by Prusa, the printer manufacturer, and it works generally quite well. Thingiverse is a little bit older, but tends to have a broader selection. The quality of the actual website isn't as nice, but Thingiverse is quite good. Cults 3D is quite an interesting one. That is home of a lot of people who sell their models. So a lot of models people put on for free. I've made this thing. For example, my shower door broke 2 weeks ago. I found an STL for a new hinge and printed it, and done. It was free. Cults is more orientated towards commercial. You're probably not going to find a huge amount of radio stuff on there, but if you want artistic things, figurines, vases, miniatures, that sort of thing, good place to look for that. Google, I mean, it's obvious, but yeah, what you want is Google thing STL, or 3D print, or something like that. There's a couple of accumulation sites of words. Yegi is a good one. It looks at the other sites, so you it's a meta database of them. And designing your own isn't as hard as you might think. FreeCAD, Fusion 360, Onshape, stick those into YouTube. There are academies, there are places, there are courses, there are people who publish tutorials for them. They take a little bit of getting hang of, I'm not going to lie, but there are some really good YouTube series you can just sit and watch. There are some really good courses you can buy that are pretty good. Props Academy do a really nice Fusion 360 one. Yeah. OpenSCAD is free and open source and is programming based to create your model. I don't understand it. Blender is on there. Blender is much more orientated towards organic shapes. It's used by the computer graphics industry to do films and things like that. It's got a learning curve. That one is hard. I've never got the hang of it. It's famous for having a user interface that is opaque, but it is learnable. People do some fantastic work in it. Another part of this talk is to try and inspire people to take up 3D printing. It's fun. So things you can print. If you're into packet radio, that's a Nino TNC in a free case. I built the kit. I printed the case. And the best thing is I got to choose what color it was. So it's bright yellow. OK. How are we doing on time? Cool. Yeah. What is a slicer? So I touched on earlier, 3D printing is layers. So what you do is you get your model. You download your model off the internet. It is a 3D model. What you need to do is work out how to print that. And functionally what that's doing is the printer is going to print a layer of plastic and then move up a little bit, or down in this one's case, and print another layer, and then print another layer, and then print another layer, and until you've got a layered thing. Which is fine, but you need to have those layers. And also what you need is the code to tell the printer where to move. It's moving in 3 dimensions. So you need that code. You can write that code by hand. I don't know anyone who does, but you can. I wouldn't. So a slicer is a program that takes your 3D model, converts it into layers, and then writes the code for you that you then upload to the printer. This is a neat little thing that I found on Printables. They run competitions, like design competitions with themes, and one of them was soldering helpers. Great. This is a little PCB holder. It pulls out, you put your PCB in it, you clamp it, and it rotates, which when I was building the Nino, really useful. Right, so we'll see how this goes. So this is the slicer that I use. This is called Orca Slicer because it happens to have a pre-built profile for this printer. Other names you may come across, Prusa Slicer, mostly for Prusa printers, Bamboo Studio for bamboo printers, Cura is another one. Cura works really well. It's quite an older program, but it's still maintained, it's still updated. It's quite nice, but it doesn't work with this printer, so I don't use it very often. So what I've done here is I've loaded my model, my volume knob for my radio. On this side, I've told it which printer I'm going to use, what material I'm going to use, which we'll cover in a minute, and what settings I'm going to use. So when I say everything's layers, the quality of a print is determined by how big those layers are. You can imagine if your layer is 1 inch tall and your model is only 1.5 inches, that's not going to work. I mean, you can't have inch layers on a printer. But so we work in, it's actually microns, but everybody quotes them in decimals of millimeters because I don't know. So this is 0.22. 0.20, sorry, which is each layer will be 0.2 of a millimeter tall. For a modern printer, that's a relatively standard print. If you've got an older printer, 0.3, 3.5, 4 might be more common. If you want super high quality, getting down to 0.1, 0.2, 0.12 is common. The other flip side to that is the more layers you've got, the longer it's going to take. So there's your trade-off. You can have high quality, but your thing that this is tall is going to take 4 days. Or you can have slightly lower quality, and it might take 3 hours. The thing with the slicers is that they will tell you how long they think the printer is going to take. It's not always accurate, but it's close enough. And then, if I can, Annoyingly, this won't full screen, so I can't actually scroll down. No. Okay. There are a couple of other things that influence what your print will look like and how it will act. You can do, so, some prints you want to be strong. They're a door hinge, they're my shower door hinge. That means what I want, your initial instinct would be, I want it to be solid plastic. That's not actually as strong as doing it 90% plastic because you eliminate the chance for it to flex. So what I mean from that is the infill in the print. If you imagine a cube, the infill is how dense it is, how much it has filled the inside of that cube. And that's measured in percentage. So anywhere from too low and it won't print, so 7% is about the lowest you can get, all the way up to, you can do 100%, you can print it solid if you want. Again, that also affects how long it's going to take, because you're printing more things. And the other major strength indicator is how many walls it's going to do. So if you've taken your cube and hollowed it, and then you've printed some infill in it, how many times it's going to go round the edges. Because if you only do it once, this plastic doesn't stick together that great. It's probably just going to snap, which is fine. If you're like, hey, I need to see whether this fits, print it as fast as I can. I want it in 20 minutes, go. But if you want something strong, the classic example would be the Voron printer parts, which, like parts of that printer are 3D printed. They do 5 walls with 40% infill. They consider that to be the strongest you can get. I don't know whether that's true, but in terms of things you might need to know as a beginner, when people are talking about infill and walls and ceilings and floors, that's kind of what it means. You can experiment yourself for what you want. But then, if we go to a preview, it's not going to show me because everything's massive. Great. You can just see, will that go away? No. Okay. You can just see like the slicer has pulled down and worked out how much time it's going to spend doing walls versus infills versus outer walls, inner walls, tops, bottoms, things like that. So you can see like, oh, if you want this print to go faster, you can see what you're doing the most of and change it. Cool. I appreciate my demo there wasn't ideal. Did that kind of make sense? Yeah? Everyone feel like they might be able to shove some terms into Google and get some definitions. Great. Okay. Oh, no, we did that bit already. Filament types. There's a bunch of types of filament. Different brands call them different things. They're not always true. The standards are PLA, PETG, PETG, depending how you pronounce it, ABS, ASA, and TPU. That's a bunch of acronyms. What does that mean? PLA is what this printer is currently printing. It's finished. Excellent. It's cheap. It's pretty easy to print. It comes in a range of colors. It comes in a range of materials, of mixers. The internet will tell you that it is compostable and biodegradable, and therefore it's fine because it's technically a cornstarch, not oil-based plastic. Yes, also no, in a meaningful amount of time. Yes, it's technically biodegradable if you've got geological timescales. It's not going to compost in a meaningful amount of time, which is a shame. It's plastic. Being mindful about the environment is important, and plastic that doesn't degrade is a bit annoying. Very annoying. PETG, so PLA is quite brittle. It's pretty good. It's pretty dimensionally accurate. It's quite brittle. PETG is a bit better. It's got a little bit flex to it. It's also fairly easy to print. It has a couple of different qualities. But it's also pretty cheap. So in terms of cheap, PLA, I'm paying about £10 a kilo. PATG, probably 15 a kilo. And then you've got the things that need specific printer features. TPU is a flexible filament. Unfortunately, I didn't bring my Brompton, but my Brompton has squishy parts on it to keep the locks in line. And it's genuinely squishable. Like, it doesn't quite work as a bouncy ball, but it's quite abrasives. So TPU needs a specific feature called a direct drive on your printer. Most are now. But yeah, if you're looking to print TPU, you need a direct drive printer. Abrasives, there's a good mix of filaments these days. Like you can buy plastics that have carbon fiber embedded in them, or marble, or wood, or brass. They look super cool, and particularly the carbon fiber, it's much stronger. It has a really nice attributes, but that will destroy your nozzle if you put it through a brass nozzle, which a lot of printers are. They are literally abrasive, and it particularly glow in the dark. Glow in the dark has ground up glass in it. It is literally sandpaper you're putting through your printer. You can get hardened steel nozzles. That's what you want. And harder to print and more durable, ABS and ASA, they're a styrene-based plastic. ABS is pretty common, like injection molded plastic. They are harder to print. They warp as they cool. So you need a printer in a box, and it needs to be heated, ideally. But they are super strong. They're UV stable, so you can use them outside. PLA, don't print a part for your radio in your car in PLA. Its melt temperature is 60 degrees. That's quite easy to hit in direct sunlight in a car. It will melt. Not dribbly melt, but like your box will go like this. ABS and ASA, their glass temperatures are over 100 Celsius. If you're hitting that in your car, you've got more problems. And yeah, someone mentioned stands for radios. That's my G90 with a 3D printed stand with a little, I actually inverted one of the stands and clamped my Nino to the top of it because I do pack it. Safety warning, ABS ASA contains styrene. That is toxic. And if you're printing it and melting it, that is an airborne toxic. Print them in enclosures with filters at a minimum, or do what I do. I print mine in my garage, and my garage has enough holes in it that it basically counts as as printing outside. Things get hot, and things can move unexpectedly. It's very easy to go, ooh, that's gone a bit wrong, put your hand in the printer while it's working. Don't do that, it hurts. Picture, that's some cable mounts that I printed for fitting solar panels on the roof of my van. How are we doing on time? Yeah. RF and filaments, this is a radio talk. There's not a lot of public information. A lot of companies have done studies for it, but they don't release the studies because it's commercially sensitive. ABS, PLA, ASA, they're generally considered to be RF transparent because they're used all day, every day. Don't put your printer in a 4-foot cube of PLA, like that's probably not going to be transparent, but in terms of putting it in a box, probably fine. Mixed material filaments, so the filaments that have metal in or carbon fiber or anything like that, they're probably not going to be RF transparent. I was having an interesting discussion earlier about, can you 3D print an antenna? I don't know, but now I really want to find out. There are now RF-specific filaments. There are filaments you can buy that have known dielectric properties. People are printing microwave antennas, which I only discovered while Googling this last week, and that's cool. And yeah, you can get conductive filaments. They have a high enough metal percentage in them that you can print circuits, which I don't know why you would, but it's kind of neat. Again, this is a little 3D printed desk cable holder. Sticks on the side of my desk, holds all my little USB cables and such. I looked on Amazon. These are £6 each. That's like 18 pence worth of filament. And probably the same in electricity. Choose a printer. It's 2024. Printers have improved. If you've got or come across MakerBots, the early Crealities, things like that, they're great. They're well-known names. Don't buy one. Controversially, the internet is going to hate me for this, don't buy an Ender 3, which are the common printers. I had a picture of one as a 3D printer. They were released in 2018. And yeah, they've improved them, and there's a whole bunch of aftermarket support. My kind of thing with that is there's a whole bunch of aftermarket support for a reason. Don't get me wrong, if you've got an Ender 3, don't throw it in the bin and buy something else unless you really want to. But there are better options at the same price range now. So things you want. Heated flex plate. What does that mean? Right, well, print beds, modern print beds should be heated. If you've come across a printer that doesn't have a heated bed and you're not buying it for a very specific reason, don't buy it. It's not worth your time. Ideally, don't buy a glass print bed in 2024. This actually ships with one. You'll notice it's not glass anymore because I changed it. And yeah, flex beds. So the problem with printing is your print is on the print bed. It's stuck to the print bed. If you've got a magnetic flex plate, then getting it off, you take it off like that, and you go like that, and your part just pops off. You'll see a lot of talk of people saying, oh, you can't buy a 3D printer without you buying a scraper and a whatever, and like, just buy a flex bed. Just get a printer with a flex bed. So, yeah. There you go. What's that? 20 minutes? And I got to choose what color it was. Because everybody's got one of those radios, so having a green bit on it, it means I know which one's mine. Direct drive. Direct drive means the actual gear mechanism that's doing the extruding is at the print head, which means it's pushing the gap between where the plastic comes out and where it goes in, has all of the bits in it. This is really important for printing TPU because it's flexible. Older printers, or some design printers, this one particularly, are Bowden printers, and they have the extruding mechanism further away from the print head. If you're printing a TPU flexible filament, it can't push the filament into the print head because it just flexes inside and it all turns into spaghetti. Direct drive means you can just print straight through. Most printers these days are. A 300-degree minimum hot end. Some filaments need higher temperatures. If you're buying a printer in 2024, buy one that says it can do that. Realistically, it's not. You're never going to get to 300. I print at 220, 250. But one that's, as ever, one that's quoted at 250 will not do 250. Core XY, getting a little bit technical here, that's the architecture of the printer. Core XYs are belt-driven. They're usually distinctive in that they're a square box frame and the bed moves up and down rather than forwards and backwards. They're generally much faster, much more reliable. And it should run software called Clipper. That's all you need to know. You can, if you're looking at a printer and it says Clipper, get that one. If it says Marlin, kind of know what you're getting into. Maybe Google it. Probably implies it's an older printer that they've rebranded. Not always, but on the whole, if you're choosing a printer, look at that. Choosing a printer, part 2, brands. Bamboo Labs, Prusa, Eligo, Creality, Creedy. Bamboo Labs are the internet's darling at the minute. If you don't have a fundamental objection to a closed source ecosystem, which a lot of people do, and that's entirely legitimate, buy a Bamboo Labs. That would be my, if you would, My recommendation as a beginner for a 3D printer, if you, at whatever budget you've got, if you're new to it, these days, buy a Bamboo. Prusa are also extremely good. They tend to be a bit more expensive for their capabilities, but their aftermarket support are brilliant. They're like, Prusa are great. For a long time, they were the leading printer company. Elegoo, Creality, Queedy. My advice for those is you can definitely get some good printers from them. Do some research, read some reviews, watch some reviews on YouTube before you choose the specific printer. I, for example, run a Creality K1 Max as my big printer, which is this big, and 30 centimeter square cubed print bed. And this one, which is a positron. Avoid, as a beginner, avoid a Voron. Vorons are kits. Well, technically, Vorons are designs that companies then sell kits for. Sounds like a great idea, because, hey, I'll build it from a kit, I'll learn how it works and the rest of it. To build a Voron, you need to own a 3D printer. Or you need to buy the 3D printed parts from someone else. I have built a Voron, I own a Voron. I can't honestly recommend one to a beginner. Know what you're getting into if you're going in around a Voron. Again, avoid kit printers, apart from Prusa. Prusa's kits are really good. They're fully documented. They ship you some gummy bears in the box. They're really nice. Large format. So my K1 Max is 30 centimeters cubed. That brings its own problems. The quality I get off my big printer isn't as good as I get off my small printer because physics. It's physically moving things, heavier things around. Nothing to say you couldn't, but as a beginner for your first printer, maybe don't, unless you specifically have a need for a large printer. And again, as a beginner, don't buy a printer from AliExpress. You can definitely buy good printers from AliExpress. Try and buy one from somebody who at least has a semblance of aftermarket, like customer support. My Voron came from AliExpress. That's not true, actually, but yeah. And yeah, in terms of things around the shack and around that you might be useful, this is a system called Gridfinity, Zach Friedman designed. It's basically a storage unit system designed around 42 millimeter square units. So you print a base plate and you print boxes of various sizes and they all fit, which for parts boxes, absolutely incredible. My printers spend most of their lives printing small 42 millimeter variant boxes. But this is a Gridfinity box. This is the grid system with some 5x1, two 4x1s, and that's a Hantec oscilloscope that I found the design online, download, printed. It just slots in it, and it all fits in the box, and the box shuts, and it goes back on the shelf. And that's custom fitted to the kit that I own. Thank you. Yeah, Gridfinity, for me, is nearly worth owning a 3D printer in its own right. And if you are going to do Gridfinity, try to get a fast one. My budgets page has vanished. Okay. Let's go back to this one. I know what I'm doing. I can give talks, honest. Different budgets. At about £300, you can get a very good starting printer. The Bamboo Labs A1 Mini base price is £170. Its print bed is 120 mil. I'm probably misremembering that. It's roughly about the same size as that, maybe a bit smaller. That's modern enough to get started printing things. The other thing with 3D printing is there's nothing to say you can't print one big thing in small parts. They also, Bamboo, do the AMS, which lets you put multiple filaments connected to the printer at once, including multiple colors, multiple types, multiple whatever. For the A1 Mini, that's £300. Creality do a bunch at that price. Decent. £500 is kind of your next step up. At that point, you start getting into the Core XY printers, printing 256 squared pretty quickly. And at £1,000, just buy the Bamboo X1C or the Creality K1 Max or something along those lines. So yeah, like you can get started with a good printer for £170 plus some filament. Like that extra £30 to £200 gets you 3 rolls of filament. And the last thing on this slide, accessories you might want. You don't need, but you might want. Filament dryer. A lot of the plastics are hygroscopic. They absorb water. If you keep them in a high humidity environment, and anything over 30% counts as high humidity, and high, we live in the UK. The humidity here right now is about 70. Filament dryers are basically dehydrators that take a filament roll. You can just buy a dehydrator from eBay or Facebook Marketplace. They work just as well. 3D lac is a little spray that people used to use non-scented hairspray. It's basically that. It helps the print stick to the bed a little bit. It's not required, but it can help in certain circumstances. Never use it with PETG. PETG sticks like nothing else. And yeah, if you then add more stick to it, that print's not coming off. Plastic razors or scrapers, handy if you have stuck it to the bed. Hardened nozzles for printing abrasives, kind of useful. Tweezers, generally useful when it's spat out some plastic and it's hot and you need to pick it up. Isopropyl alcohol, yeah, the print bed, like if you touch it, you'll get oils on it, cleans it up, and I'm done.
Fantastic. I don't think I've heard so much new information than any other lecture this weekend. Any questions?
I've actually got an Ender 3.
I knew there would be someone after I said that.
But it is a V2, and I've been very pleased with it, and I've done a few modifications. But for my CAD, I use a thing called Tinkercad, and I found that very much easier for anyone just starting out.
Yeah.
Tinkercad is brilliant. I mean, you can move on to the bigger ones.
Yeah, yeah, that is a good recommendation. I started with Fusion 360 because I'm an idiot. Yeah, Tinkercad is a good place to start. The other one that they've just started removing it, but the Microsoft 3D Builder, I think that ships in Windows 10 and 11 in the App Store, actually surprisingly genuinely good as a beginner. They've just stopped supporting it, but it's still available, I think. Yeah, it's also a really good place to start.
Keep your filament in the airing cupboard.
Also a good tip.
Over there.
Thanks. I desperately need some decent storage. So what's the storage box that you had? What size of printer would you need to do that? Is that printer there big enough?
That particular box, no, it stands about that. I printed it on my K1 Max, which has a 30 centimeter print bed. 256 by 256 is the sort of modern standard, because that's the standard that Bamboo now uses their standard, and everybody's sort of copying them now. So 256 by 256, a lot of models are designed for that size because it's very common. The thing with Gridfinity is it will scale as big as you like. If you've got a printer this big, you can print a thing this big. But yeah, useful sizes start probably over 200 millimeters.
Labs A1 Mini you quoted, would that do that box?
No.
No. Okay.
You'd want the A1 full size or going up to the P or the X series.
Right, thank you.
So we're a bit out of time. I'd suggest if you've got more questions, you can ask Jim at the
I'm
front.
more than happy to talk about 3D printing all day. So
Thank you very much.
Yeah,
Fantastic lecture.
Thank you.